Currently, we have a parabola. This parabola doesn't pass the horizontal line test. So if we did the inverse of it, the inverse would not be a function. It would be a sideways parabola just like we've seen before. This question is saying, but maybe if we didn't take the whole parabola, maybe we could make it work. So the question says, determine 2 ways to restrict the domain so that the inverse is a function. Okay, first thing I'm going to get you to do is our vertex is going to be really important, so I'm going to label it at 1, 3. And then I'm going to get you to, you don't have a ton of space, but somehow in what you're going to write, split it in half. And we're going to do restriction number 1 and restriction number 2 separately and do all the work for each of them. Now, if a function passes the horizontal line test, then its inverse is a function. Can you see that if you only took half of the parabola and ignored the other half, then it would pass the horizontal line test? And we can talk about only half of the parabola by restricting the domain. So I'll do this in green. Restrict the domain to x is less than or equal to 1. If we only take half the parabola, if I take the part to the left, it will pass the horizontal. Similarly, in the second way, I could restrict the domain. I'll do this one in purple. You see that it would also work if you took the values bigger than or equal to 1. Both of those situations would work. Yes?
How does that make that pass the horizontal line first?
Okay, I'll draw a horizontal line. Okay. Does it pass there for 1/2? If I only, the green part is, I'm only looking at the green part. Does it hit the green part twice? Is there anywhere I can make this horizontal line hit the green part twice?
Oh,
Okay. And then this restricted domain is saying, now I'm only doing the purple part. I'm saying I only consider x values bigger than 1. Is there any place I can move my horizontal line to hit more than 1 point on the purple part? No. But when we put the green and the purple together, we have problems. Now the question says to find the equation and use a graph. I think it's going to be easier if we start with the graph. Okay? So if we did the green graph, it has 1, 3. It also, that is not green. It also has 0, 4, and -1, 7. Those are 3 points on my green graph. If I wanted to do the inverse of the green graph, I would now have instead of 1, 3, 3, 1. Instead of 0, 4, 4, 0. And instead of -1, 7, 7, -1. And I would have this half of the sideways parabola, the bottom half. Now to find the equation, we find the equation by taking our original equation. So our original equation was y equals x minus 1 squared plus 3. So first I would get switch my x and y. So I get x equals y minus 1 squared. plus 3. Switch my x and y. Gonna get y by itself, so move x minus 3 would equal y minus 1 squared. Get the squared by itself. Square root both sides. Don't forget the plus or minus. And finally, move the 1 over. Now the inverse is only going to be one of those for the restricted domain. Part of the reason I did the graph first was I think, if you look at the graph, should I have a vertical reflection or not, based on the graph that we drew? Think of a regular square root graph. Has it been flipped down? Yes. So my graph tells me this one is the negative. There are other ways we can tell that it's going to be the negative one. Second way we can tell it's going to be the negative one. If you restrict your domain on the original one to x being less than or equal to 1, and x and y changes everywhere, can you see once you switch that our range will be restricted to y being less than or equal to 1. If our original domain was restricted to x less than or equal to 1, then our range will be restricted to y being less than or equal to 1. Which, can you see that on the graph, that it goes down? And if y has to be less than or equal to something, can you see that this number needs to be negative? So there's an algebraic way of looking at it. Now that we've done the green one, we can switch and do the same thing for a purple graph. On our purple graph, I look at points on my original graph. I have 2, 4, 3, 7. So again, I have 3, 1, but now I have 4, 2, and 7, 3. That's the inverse of the other side. And whichever equation we didn't use from our work on the left-hand side, notice we used the negative one. So that means for the purple one will be the positive one. X minus 3 plus 1. Doing the graph first can sometimes also help you find the equation. Okay? If you started off with a regular square root graph, you see that this one has had a vertical reflection. That would move it down to here. And then it looks like it's been moved 3 to the right and 1 up. Do you see that our green equation has a vertical reflection? 3 to the right, 1 up. The second one just looks like, here's our square root graph. Move it 3 to the right, and then move it 1 up. Matches up nicely that way as well. Okay. I'm gonna ask you this question on quizzes, I'm gonna ask you this question on tests. One of the things that I find people get confused about is this, what does it mean to restrict the domain? Okay? Restricting the domain is doing something on the original graph. You're taking the original graph and you're only taking part of it. On the exam, I've never seen this question asked on any other function other than a parabola. So on a parabola, it'll always be your vertex that's really important. Because taking half of one side and half of the other is what's going to make sure that you pass the horizontal line test. So your restricted domain is going to be connected to your vertex, in particular the x-coordinate of your vertex. So I go left of 1 and right of 1 because that's the x-coordinate of my vertex. If my vertex was somewhere else, it would change what I would restrict my domain. And then once you've got your domain restriction, I color-coded it so that I could draw each part separately. I think on your test or quiz, I even give you 2 graphs right away so you can split your page easily. Hopefully, the idea was to make that easier. I don't know, I'm still trying to find the easiest way for you to be able to do this on a quiz or a test. So, questions for practice for this one are, did I give them to you already? 10 and 12.